Hi guys, we're going to present.
Joaquin, real quick, I have a question.
Oh,
Not a question.
Are you coding?
yes. In this particular test, I am. Yep. So, hi everybody. My name is Joaquin Lara, and
I'm Daniel May.
and we're going to represent Robot Writer, Rutgers official robot writer, patent pending. So the objective was to create a web application that communicated with the hardware. We wanted to bring manufacturing to the household. Initially, we had a machine laying around that had been abandoned, needed tender love and care. So we took it home and we developed a web application where you could take a picture and send the picture to our pseudo manufacturing facility. So we would take that picture, render it into an SVG file, and print it out physically with the machine.
Here's how we did it. We did our version control with GitHub. We coded in Sublime, Cloud9, and JS Fiddle because there was a lot to do and many different platforms in which we had to do it. The front end was taken care of with HTML5, CSS3, JavaScript, jQuery, and serialize. Our database was handled with MySQL, and we used Node, Express. Chili Pepper there is the middleware that converted the image to math, which is called G-code, and that's the technology used for that. And the Arduino and Gerbil is how we communicate that machine G-code from the laptop to the robot to print. So those are critical components in what we had to use. Handlebars is just how we kind of developed everything to the front. And Bauer helped us with our dependencies. And for the physical side of things, it was hand and power tools.
Yeah. Basically, duct tape and
WD-40s and paper clips. So that was how that happened. The database that we created it so it would store the 5 most recent uploads. This way you wouldn't have to worry about like losing the picture and not having a double, or maybe it didn't come out quite right in your eyes. You can edit it somehow. So you could always go back and get it again. All right. And just this was an example of our table, how things would look on the back side.
So we simulated a user case where someone obsessed with kiwis, who wanted to print several kiwis, would be very able to print several
And they are
kiwis.
nice birds. And just the logic behind the overall data handling and access.
Yeah, so we kind of talked through how a user would take the picture, upload it to a SQLite database, which is an extension of SQL, and we would store the images in an Excel type format, CSV, for later use.
And that particular format's friendly to all different kinds of other, printing and graphics related things. Again, we have it up on, it is still on the repo, and GitHub was mainly used for our version control. Okay. This is actually the robot, and that was the front end that we had done for it. The whole thing was, we wanted to have a simple landing page so you knew where you were, and you could either sign up on the left, or you could use your passport and Facebook to log in on the right. Simple sign-up process with your Facebook account and your writing.
Authenticating with passport. We were also thinking in the future to implement some way to just be able to remotely print or remotely transfer, user requests to a workshop, so that nobody would have to be monitoring the process of the machine. It could just be automated, plug and play to an Ethernet cord, and just have it run.
Mm-hmm. And this is what you would be watching while a job is being printed. That little peg in the middle there would denote the carving head or hot head or pen or whatever we're using at the time. And its graphical representation is where it is physically on the carving, cutting, printing surface. And we do have it real quick,
We have a very short video. It's a treat for you guys, especially prepared.
I need you. Oh, treat. Or not. I need you. Take two.
There you go.
There you go.
Yeah.
There's no sound, but you can clearly see how
Make it full screen.
Yeah.
focused we are on the task at hand.
Bottom right.
We rigged a pen to the machine to be better able to
There you go.
Non-jittery good part.
So that's
Another
Doing this.
post-production. This will look a lot smoother. Please stay tuned for the media release.
You can also check it out on YouTube, right?
Yes,
Yes,
sir.
there is a clip of it running around. on YouTube.
Rutgers' very own robot writer. Patent pending again. Not really.
And that was our fine construction approach at the time. And it's typing the word, it's writing the word settings, which if you look in the back, you'll see that.
Yep. Unfortunately,
We were trying to depict everything at once. It didn't really go quite right, but you know.
Unfortunately, at the time, we kind of reversed the polarity of one of the motors, so it's printing backwards until we just fixed the bug.
But a lot of fun was had, a lot was learned, and a lot was accomplished. It did work. It passed successfully, and it's just something you can do with like 50 products in some time.
Joaquin, well, I have a question.
We allow 7 follow-ups.
All right. So first question. All right. What did you use for the printing? I mean, for the actual code to actually like tell it to print this image. What was the connection there?
Luckily, the technology that we mentioned previously, Chili Pepper, is an open source tool that allows you to communicate with regular hardware
So you can
using.
communicate with Arduino?
Yes.
Yeah, it communicates to the Arduino, and the Arduino communicates to the motors. So we didn't have to pick up C++ or anything. No machine languages included in this kit. We just used JavaScript. We sent the request, and it was easy plug in and play.
All right. Second question, and then I'm going to take over his million. Have you thought about doing 3D printing with this?
Well, it's just this is primarily for CNCing with the controller that we were currently using, but there are more advanced versions of this controller that are readily available for $130.
Right.
So
Because I was thinking like you could use that controller and then like a 3D printer that you could do for like $200.
yep,
And you could just
CNCing,
like create like iPhone cases or whatever you wanted to, you know.
absolutely, it's very possible.
Right.
It just needs to be implemented.
So this is a two-part question. I was wondering what the biggest challenge was for you guys with this project. And part B is for Joaquin. What are you wearing?
Oh my god. Daniel, would you like to answer both? Would you like to answer the first one?
Challenges. There was it really was pretty down the line. Like there was, because it was kind of a salvage machine, there was a lot of things that you don't see coming when you're working with that equipment. So you know, when it does whatever it decides to do, you just have to be ready for it. So there was that, a lot of that. The code was most, I think, challenging, just trying to get the actual display with the peg that we displayed earlier, to get that view correct was very challenging because like the native widgets require certain dimensions that we were trying to avoid, and it didn't like the new ones at first, but you know, eventually we made up.
I got one last question. Why are you guys breaking it apart? If I had made this, I would have it on my bed, I would look at it. You guys are breaking it down, right?
Yeah, we're cannibalizing it for parts. Reason being is we have high standards, and it was it was made with scrap parts. I'm not entirely proud of it. I want like pure production, absolutely professional grade. So once we have the funding for that, if anybody's interested in funding our project,
Put it on Kickstarter.
we'll get to building it from scratch again. But thank you very much, guys.